Hello everyone. So let's start with today's discussion. Well, in the previous class, we had talked about a couple of things. Let's just recap them. We had talked about force, momentum, Newton's first law of motion, inertia. Second law of motion also we have done quite a bit. We'll just discuss about the applications today. Okay, so what was force exactly? We had talked about the fact that force was a cause that tends to change the state of rest or uniform motion of the body. The term uniform here is important. Now, why is that? It is because if it was non-uniform, then it would mean that it already has an acceleration, right? Because uniform motion matlab the speed will be constant, right? Now, if the speed is not constant, means that either it is accelerating or it is decelerating. मतलब अगर 1 second में the car was going, for example, at a speed of 2 meters per second, then after 2 seconds it is going at 5 meter per second. Sorry, not second square, it will be second because the unit of speed is meters per second. Okay. Yeah, so anyway, so this means that it is not uniform, because if it was a uniform motion तो फिर 2 seconds बाद भी 2 meters per second होता, 3 seconds बाद भी 2 meters per second में the car would have gone. But since it is not happening, means the speed is not constant, मतलब it is accelerating, so it is non-uniform. But as a result of which, force will always cause a change in the uniform motion of the body, because if it is already non-uniform, matlab you know that koi force pehle acted hua tha on the body, right? Like a force had previously been like changed the state of rest or motion of the body, because it made it non-uniform. So a force is a cause that changed the state of rest or uniform motion of the body. Acha. Now we talk about momentum. We had learned P equals to M into V. इसका मतलब था M stands for mass, V stands for velocity, and momentum or the impact that happens when a car or a truck or anything like sort of crashes onto another object, like the impact to which it happens. How do we measure the impact, right? So we measure it by the product of the mass and the velocity of the object. Now I gave a very gory example, like a truck or a car, an accident. Like you don't have to go there. We can use some easy examples also, like you're catching a ball. Okay, so if the person throws at you at a small speed, then you won't feel that much. But if the person literally like full force laga ke like throws at you, then you'll feel something, right? You'll either feel hurt or feel a little discomfort. So that is the thing. It depends on the mass and the velocity of the ball. Now, instead of a small ball, if he would have thrown a big ball at you, even if in a small velocity, you would have gotten hurt, right? So that is the thing. Next comes Newton's first law of motion. We had talked about it. It's kind of related to force and how it is applied. So if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it is acted upon by a force. So a force, or specifically unbalanced force, is basically responsible for causing the change. Okay, that happens in the body, as a result of which it will either change its state from rest to motion, or from uniform motion or constant speed to non-constant speed, like variable speed, from where the acceleration concept comes in. Okay. Now what is inertia? Inertia is the property by virtue of which a body resists change in its state of rest or motion. Okay. So अभी लॉकडाउन में क्या हो गया है, like we are bored, we're at home all day. Like I myself am a medical student. Okay, I'm in my second year studying medical, pursuing medical, and I have become so lethargic because classes अच्छे से नहीं हो रहा है. The moment offline classes will start, it will become very difficult for me to go back to my college, to go to wards, to study, because I have been so used to this lifestyle of like waking up at 11 and all. So everything in this world, like not just human beings, everything in this world is like resist change. Okay, उन लोगों को change पसंद नहीं है. In the same way, anything, like we talk about a stone, we talk about a car, a truck, everything, it will not change its position or state of rest or motion unless it is pushed, unless you apply an external force on it. ठीक है? External is important because internal does not count, right? Whenever an external force will act on you, that will lead to the change of a state of rest or motion of the body. So the property by virtue of which a body resists change in a state of motion, matlab if a person is sitting, unless the person is asked to, or rather pushed to, like please get up, the person will not get up. Why? Because he has an inertia of rest. We had talked about some examples of inertia. It was like when you're driving a car, when you're in a car and suddenly the brakes are applied. So what happens? Your upper part of the body tends to move forward. Why? Because it thinks that oh, abhi bhi motion ho raha hai, abhi bhi the car is moving, but the car has actually stopped. And the lower part of your body, along with the seat and the carpet and everything, it has stopped, right? So the lower part is stopped. Like I'll just draw again. So if you're sitting, and the lower part, so basically what happens is the lower part of your body, it will stop along with the car seat, but the upper part, it will move forward because it is still in that inertia of motion of the car जो 1 second पहले ही था but अभी नहीं है. Just after a few milliseconds, the person will think, okay, no, the car has stopped, so it will again move backward. Same thing. Okay. So now let's go over Newton's second law of motion. That was our last topic of the last class, which was the rate of change of momentum of an object is directly proportional to the force applied on that object, and the change is in the direction of the force. Okay, now you can pause the video and you can like copy the definitions if you want, or you can later find it out from the PDFs that we'll give along with the description of the video. Now there's a typo here, just this will be the change, so just cross the Y here, be good to go. Yeah, so the rate of change, so rate we had talked about, anything per unit time is rate. Change matlab final or initial के बाद like बीच में the amount that you're like going by the velocity, going by the distance, anything change matlab final minus initial. Directly proportional, we'll just discuss it a few minutes later, what Newton's second law of motion is. Again, so the basic, after the derivation that we had done, basic जो आया था, that was F is equals to K for constant M into Vf minus Vi by T, right? And Vf minus Vi by T, it's a formula for acceleration, right? We had studied in motion in 1D. तो ये हो जाएगा K into M into A. So this, and since K, due to maintain the proportionality, we had given here a constant, and बाद में it was found out that the value of K is 1. तो यहाँ पे we can or cannot write K is the same thing, so it gave us F equals to ma. So this was the main finding of the second law, which is force equals to mass into acceleration. Okay, now this is very, very important, you have to remember it. Okay, So this was about the last class. Yeah. So now let's talk about a little bit more about the second law of motion. जैसे कि we had done the derivation the previous day. उसमें से last में यहाँ पे भी है, if you can see. F equals to m into v minus u by t. U is nothing but the initial velocity and v is the final velocity. So yeah. So now what is this cricketer doing here? A cricketer is lowering his hands while catching the ball. Any idea why? So here, if he keeps his hand here और यहाँ से ball आया तो directly let, for example, like the ball is thrown from an arbitrary place. So let him take like 1 second. ठीक है. Like after the ball is thrown, 1 second बाद वो cricketer के हाथ में आ गया. Abhi, if the cricketer's hand is here at this position, let this position be A, the first position, let this position be B. ठीक है. So the B position में he's catching the ball, then obviously 1 second से ज़्यादा time लगेगा, right? So let's call it as 3 seconds. So now what is the logic behind it? Like why is he lowering his hand while catching the ball? Because as you can see the time, he's increasing the time of impact. Now why is he doing that? F equals to m into v minus u by t, right? Abhi, let's see what happens if this t, okay, here we are basically increasing this t, right? 1 second से अभी हो गया है 3 seconds. So as a result of which the time of impact is increasing, and you know that when a denominator increases in magnitude, force का क्या होगा, मतलब right side left side में जो है इसका value decrease करेगा कि increase करेगा? It will decrease, because why? Whenever the denominator increases in magnitude, on the opposite sides the value decreases. Why? Because let's say mass obviously for everybody it's always constant, right? So we can also write this equation as in the form of a proportion equation. F is directly proportional to v minus u by t, and we know here अगर simplify करके लिखे तो we can write it as f is inversely proportional to t. If we take this as constant, this I'm just for the sake of explaining you, I'm saying it, ये constant change कैसे constant हो सकता है, but I'm just saying कि we can think of it like this कि f is inversely proportional to t. So t, whenever t increases or the time of impact increases, the force or the impact, the amount of impact, it decreases. Okay, so basically he's lowering his hand so that he feels less hurt. Okay. So this I can tell you guys another example, like whenever like you fall on sand, okay, and you fall on cement, so obviously you get hurt more because of the same reason. On cement, because the time of impact when you are falling on sand is obviously more, because sand, like it is made up of like thousands of small particles and you sink a little, right? So what time of impact बढ़ जाता है. लेकिन cement में you're directly falling, and as soon as you fall you get the reaction force and you get hurt, because the cement is also putting a reaction on you immediately, and sand takes a little time. So that is another example. So in tests you'll get explain why this happens. So you have to write according to the second law of motion, F equals to m into v minus u by t, or F is inversely proportional to t, and then you can give these two equations and then you can explain in your own words. Okay, so the next is Newton's third law of motion. This is a new thing. Actually not, this you have used all your life, you've heard it in a lot of movies and a lot of things. It's a very basic law. it states that every action has an equal and opposite reaction. Now, this is the basis of everything in this world, right? If this law did not exist, then there would have been no manufacturing of cars. There, literally, people never would have found out how to walk, because walking also involves this law. So basically, this law guides everything that is happening in this universe. So let's take this example. The man is basically on the edge of the boat and he's trying to jump. Okay, it's a funny thing, like why would you do it? But anyway, so what is happening? As soon as he's jumping, he is going forward, but he is also pushing the boat. Right now, how is it possible that you're falling and at the same time you're pushing the boat also forward? It doesn't happen, right? So what is happening exactly is that it is not exactly pushing it. Okay, so when the man is jumping from the boat is also exerting an equal and opposite force, which is here called the reaction force, as a result of which the boat is moving in the opposite direction. So the man is falling forward, that is true. But as soon as he is falling, the boat is also experiencing a force, but in the opposite direction, as a result of which it is moving backward. Okay, if it's not clear, let's take another example. Like, yeah, let this here be a boat. Here is a man, and the man is rowing. Like, he has a row with him, and he's rowing the boat. Let this all be water. Okay. So what is happening? You've seen that whenever if you have also paddled in water in those motor boats, or if you've actually done boating with proper equipments, you've seen that whenever you are pushing the water backwards, but in turn you are moving forward. Now how is that happening? If you are pushing the row backward, it means that you are exerting a force on the water, right? You are exerting a force on the water with the help of the stick in the backward direction. And what I told you with Newton's law, that the water will also exert a reaction force on you. So if this is the force by the man, which is backward, this is the force by the boat, as a result of which when the man pushes the row backward, it will move forward. That is the whole basis of boating, right? So it means Fm is equal to Fb, but the magnitudes are the same, the direction is not the same, right? So if I remove the mod, it will basically be force exerted by the man is opposite of the force exerted by the boat. Water. This will be water, water. So because of the force that the water exerts on you, when you exert the force on the water, the boat moves forward. Okay, just erase the thing for your better understanding. Water. Yeah, so the force exerted by the man backward is equal and opposite to the force exerted by the water on the man or on the boat, whatever. So if you see in the examples, the action and reaction force always act on different bodies and never on the same body, right? Like you are exerting the force on water, man is exerting the force on water, but water is the object. And when water is exerting the force, it is exerting the force on the man. So here man is the object. So you can very well understand that the action force and the reaction force, they always act on different bodies, and that is why motion happens in the first place. Okay, so this is one of the main key points that you have to like एकदम अच्छे से याद करना होगा. Okay, they are always of the same magnitude, we already discussed it. Their directions are always opposite to each other, obviously. Action and reaction force are never in the same direction. यहाँ पे, so that's why you give the minus sign. Why? Because it is vector, and you to like understand the direction of anything, we always use the minus or plus sign, right? Like when we throw something, it is against the gravity, so we give minus g. I'm pretty sure you've seen our videos on motion in one direction, and if you've not, please go and watch it, they're really nice. And from there you get an idea of the sign conventions, like when do we give minus, why do we give minus. It is because it's against the gravity, gravity is downwards, and the motion you're doing, it's upwards, so it'll obviously be minus. Okay, in the same way, if we considered, like here I've given this as the positive direction, so the force exerted by the water on the man वो इस तरफ जा रहा है, that is why I've given minus on this side, but it can be the other way also, it's the same thing. So these are the pointers to learn it by heart. Another example is this book example. This I had actually discussed about in the previous class only. तो यहाँ पे क्या हो रहा है, the number of books are kept on the table, force of attraction between the book and the earth. Yeah, so mass into gravity, right? This is the weight of the book or number of books, whatever. Total, if it's a number of books, then this is the total mass and total weight of the body. Okay, so it is being exerted vertical downwards, obviously, because gravity is in the downward direction. Reaction force of the table on the book. So obviously when the books are giving an action or a force on the table will also give an equal and opposite reaction to the books, equal and opposite, as a result of which the table and the book, they remain static, they will not move. If the books were so heavy that the table could not have withstand the amount of force, then we can write FB was greater than FT. T stands for table. So as a result of which the table broke. That is under abnormal circumstances. But here, the force of attraction between the book and the earth is equal to the reaction force of the table of the book, and as a result of which both are balancing each other, and here it's no motion. Okay. So this is another concept, another kind of application of Newton's third law of motion. It's not like it always has to, like something has to move. It doesn't. Here you can very well see that one is just balancing another and they are in complete state of rest. Okay. So now we talk about another aspect of momentum, which is conservation of momentum. Okay. So what does it say here? When two bodies collide with each other in the absence is important, absence of an external force, and the total final momentum of the bodies is equal to their initial momentum. Okay. So here we have seen there's a ball of mass ma, initial velocity ua. Here u stands for initial velocity and v is final velocity. Yeah. So before collision, they were like moving apart from each other. Now let's say UA is greater than UB. Then they will not be able to maintain this distance forever, right? At some point, if UA is greater, the velocity of MA, or the mass, like ball A rather, is greater than ball B, then obviously they'll collide at some point or the other, right? And then once they collide, after that they will change their velocities because they have collided and they have both have had an impact on each other and both have exerted a force on each other. Now, whether the force is equal, whether the force is not equal, we'll discuss it later. But ultimately what we have to realize is that now their velocities are not exactly the same as they were before. Okay, so let's write these things down that we just discussed before collision. Before collision क्या था? Momentum of ball A था MA UA, बॉल B का था MB UB. So इन दोनों को प्लस कर देते हैं. Initial momentum of both the balls. If we consider the two of them as one system, not one body, one system, so we can write it as MA UA plus MB UB. Now, why are we writing it as a system? I'll tell you. Because in the conservation of momentum that we saw the previous slide, when two bodies collide with each other in absence of an external force, and the total final momentum of the body is equal to the total initial momentum. So, as soon as they collide, they become one body. Like even if it is for seconds, they become one single body. इसका मतलब क्या होता है? That it will, like both are exerting a force on each other, okay, but they are still kind of like one whole body because both of them are together, right? Even if it is for seconds, they are one single body. As a result of which, even if A puts a force on B, B puts a force on A, still it will be within that body. तो इसका मतलब है कि कोई external force नहीं है, right? If कोई external force नहीं है, that means the initial momentum of the body, which is at the moment A plus B, body A plus B, is equal to the final momentum of the body, which is basically we can write it as MAVA plus MBVB, right? So this is basically the basis of the conservation of momentum that we just studied. Okay, so you have to think like this, that even if ball B exerts a force on ball A, which is FBA, ball A also exerts a force on ball B, FAB, right? Still, both the balls are kind of one whole ball in itself, right? So their forces will be equal and opposite, and it will be in the same whole body. So as a result of which the momentum is being conserved, because the initial momentum, the final momentum without an external force, is the same for a body. Okay, so I hope this is clear. Let's move. We'll discuss some sums about it at the end of this discussion. We'll solve some sums and it will be more clear to you guys. For now, this is all you have to remember, like the derivation, and you also have to write the initial momentum of ball A, initial momentum of ball B, and according to conservation of momentum, this is the equation. Okay, let's go over to the next slide. Here, so like these concepts you're not exactly going to get in class 10, but I think that since we also like cover NTSE and all the other competitive exams at the level of class 9 and 10, so it might just be that to test your aptitude, they might just give something a little more complex. Okay, so these are just like two very basic sums that I'm going to discuss. It's basically on the Newton's third law, which is every action is an equal and opposite reaction. So in the first picture, what you can see is there's a pulley. Okay, now pulley, you know what it is. It's a simple machine. A simple machine is basically anything that like makes your life easier, right? It helps you in a way, like either it helps you by um, reducing your exertion or the amount of force that the amount of work that you do, it either reduces it or it changes the direction of the force that you apply, or it changes the velocity with which you apply the force. So in various ways it helps us make our lives easier. Like the most simple example that comes to mind is when you're fetching water from a well. So there's always a pulley. So if you pull down, which is towards the gravity, then gravity is also kind of helping you to lift the water right from the well. So that is the most basic application of a pulley. So now we have here put two masses on a pulley. Okay. So what do we see here? Okay, obviously M1 is greater than M2. इसीलिए ना वो नीचे जा रहा है. Like the acceleration, if you see here, it is downwards. Why? Because since M1 is greater than M2, by common sense, like obviously it will be overpowering, right? Like the object B here, I hope you can see it properly. The object B here, it is going upward, right? And that can only happen if the object A is heavy, right? Like it's heavier than object B. So M1, which is the mass of body A, is greater than M2. तो इससे हो क्या रहा है? Like what exactly is the concept here? If there's a force M1G, then there's also a force T, right? Like according to Newton's third law of motion, अगर नीचे की तरफ एक force होगा तो ऊपर की तरफ भी एक force होगा, right? And at the same time, here also, if there's M2G, then there's always a T balancing it. Now, under normal circumstances, if M1 would have been equal to M2, तो फिर M1G would have been equal to T, M2G would have been equal to T, right? तो एकदम वो न्यूटन्स थर्ड लॉ के जैसे. But यहाँ पे it is not the same. Like extra acceleration is coming into place. Why? Because M1 is greater than M2. तो इसके लिए क्या हो रहा है? इसके लिए we use the concept of third law, but at the same time we modify it. So basically now the modification will be that since the net motion is downwards, so we can write it as M1G minus T equals to M1A, right? And at the same time we can write here it will be different. Okay, like look very closely here. Like let me draw the body B separately. तो यहाँ पे क्या हो रहा है? यहाँ पे M2G है, ऊपर T है. So since यहाँ पे body ऊपर की तरफ जा रहा है, so T is greater, no? So here we write it as T minus M2G equals to M2A. Now at first you might seem like it's a little confusing and all, but actually no. It is very simple. It is all a matter of what is the net direction, what is the net direction of acceleration, and according to that only you'll understand. Like since here the net acceleration is downwards, then it'll make us realize that m1g is the greater force here, right? So we have to subtract tension from m1g. Only then we'll get the force, like the net force. Okay? And the same thing with equation 1 and the same thing with equation 2. So now basically we use this equation to like yahan se, like since t is the common thing here, we can like get the value of t. So that's a like you'll get it when like the way you solved simultaneous equations. Okay, so the next thing is here, the next example. यहाँ पे is also an application of a pulley, but it is a little different. क्या हो रहा है यहाँ पे? That ये वाला body like A body को तो same ही होगा जैसा हम लोगों ने calculate किया था पहले. I'll just use a different color. यहाँ पे it is m1g minus t equals to m1a. ठीक है. अच्छा a question might come to your mind कि ये वाला भी A है, ये वाला भी A क्यों है? Like why is it not A1 and A2? It is not because when 2 things or 100 things are connected by a single string or like they are connected somehow, we treat them as one whole system. And when we treat them as one whole system, you know, one whole system can only have one single acceleration, right? So as a result of which, since both these bodies are connected by the string, both of them will have the same acceleration. It will not be m1, a1, a2, it will always be a. तो यहाँ पे हो गया m1g minus t equals to m1a, number 1. और यहाँ पे क्या होगा? Like look at body B. This is a little different, right? So let's just draw the body B separately here. m2g और ये वाला आ गया reaction. Like obviously Newton's third law, so if there's a force downwards, so there'll obviously be an equal and opposite reaction upwards, right? Here we also get a T, but the tension here is surprisingly towards your right. Now why is that? Obviously because pulley, so it is being pulled downwards, no? तो यहाँ पे जो direction होगा यहाँ पे भी तो since it's the same string, तो यहाँ पे it's going this way, it's going in the right direction. So tension here is towards your right. Now tell me something, is there something on the left? There is no force on the left, right? No force. There's an m2g, there's an r, and there's a t. So now, oh, and also, like, don't have to write it, but यहाँ पे एक a भी है, मतलब it will, the m2a is also, by the way, in the same direction, right? Because a here, as you can see, is in this direction, right direction. So we can write that the force m2a is also in the right direction. So what does this mean? Like the fact that T and A, T like tension or m2a both are in the same direction. What does it mean? That the tension is only causing the acceleration in the second body, right? Because there is no force to oppose tension. कोई force तो है ही नहीं, it's zero. तो फिर m2a will obviously be equal to t. Now you might ask that why m2a is not equal to m2g. Right. Why? Because common sense, t तो इस तरफ है, m2g तो नीचे है. और someone is balancing m2g. Who is that? That is the reaction force. So basically they are cancelling each other out. Only tension is acting, as a result of which the object B is getting an acceleration and the net force m2a. So in this picture, these will be our equations. Okay, so now let us solve the first equation. तो यहाँ पे होगा t, yeah, just write it in another slide. Yeah, तो यहाँ पे it was m1g minus t equals to m1a, and for the other body it was t minus m2g equals to m2a. This was our equation. तो यहाँ पे मिल रहा है हम लोग को t equals to m1g minus m1a, और यहाँ पे we are getting t equals to m2a plus m2g. So since like both are equations for t, we can equate them, right? Like this is equation 1, this is equation 2. So we can equate them, saying m1g minus m1a equals to m2a plus m2g. Now we take the m's common, तो हो जाएगा m1 into g minus a equals to m2 into, let's write g plus a, same thing. तो or in, if we want to find acceleration, then we don't need to like put brackets. Yeah, what we can do is we can bring the accelerations together. तो यहाँ पे हो जाएगा m1g minus m2g equals to m2a plus m1a. So it will be g common लेके m1 minus m2 equals to a into m2 minus m1. So from here we're getting the acceleration as g into m1 minus m2 divided by m2 minus m1. So in acceleration due to gravity, like mostly it is 9.8, but in some cases, sorry, 9.8. Sorry, what am I doing? Meters per second square. Yeah, but in some cases it is like for getting a whole number we also use it. So we also use it 10 meter per second square. Okay. So anyway, that's not important here at this point. Just remember this formula. If by chance ever you get a difficult sum, like difficult in the sense of a higher level than yours, then ऐसा ही सम आएगा application of Newton's third law, Pulley देके, and maybe you can apply these concepts. Okay, so the last topic for today is derivation of third law from second law. Okay, so the second law is basically called the true law. We'll understand why that is. It's because both the first law and the third law can be derived from the second law. Okay, the second law basically had told us कि in the simplest manner, F equals to m into a. Now we know force is vector, so it has a direction, and acceleration will obviously have the same direction as the force. Mass has no direction, it's constant. So basically, derivation of third law from second law. So now, like what for derivation of for third law, we had basically said कि every action has an equal and opposite reaction, right? So we had seen कि F equals to m into a. So let there be a body. Okay, so body A. So it collides with a body B. Okay. So now what is happening? Since it is getting collided, and we had like a few moments later, or like few moments earlier only, we had talked about the conservation of momentum. तो वहाँ पे क्या हो रहा था कि body, like just the moment, even if it is for like a few milliseconds, when the bodies will collide, A and B, this ball B will exert a force on A. Let's call it FBA. And similarly, ball A will also exert a force on B, which is FAB. So now, if they are of the same magnitude, then M, this is also M, then what will happen is FAB equals to MA, FBA is also equals to M into A, but there's a negative sign. And why is that? Because this one and this one, both of them are in opposite directions, right? So that's why what's going to happen is, since they are in the opposite directions, they will be equal magnitude wise, because they have the same mass, but they will not be equal direction wise, right? That's why the application of the minus sign. Okay, so this was the main thing. Now how we apply second law here is that we had talked about momentum, right? So यहाँ पे क्या हो रहा है कि mv minus u by t, also if we do, which is equals to f here. So what's happening is that, one second, yeah, so here, although I've written the derivation of third law from second law, since we are in derivations, let's also like talk about this, like it will be a very short discussion. Derivation of first law from second law. Okay, it's a very small discussion, don't worry. So it's basically, the first law says that unless and until an external force is applied on it, the body will remain in a state of rest or motion. So if we like consider a body at rest, mind you, if body is at rest, then what is its acceleration? Acceleration is 0 because it is at rest, right? So F equals to M into A, which was the second law. यहाँ पे A तो equal to 0 है ना, तो फिर the force also becomes 0. So now we'll go at it backwards, saying कि if the body is at rest, matlab acceleration is 0, it means that there is no external force applied on it, which means because F here we are seeing is 0. Bas, that's it. This was very small. So that is why basically the second law is called the real law. Okay, so that will be all for today. Next day we're going to discuss some problems, and then I think the concepts that you've learned till now are going to be more clearer to you. So thank you for your patience. My name is Shatabdi, and do visit the previous videos of ExamRat, and like they are very nice. You can also follow us on Instagram or other social media networks, and also please subscribe to us. Thank you.